Hello and welcome to the Sub One YouTube channel. My name is Ray, and in this video, the second part of doing Fred's left arm or hand, we're going to look at installing the servos, look at modifying it a little bit to install a PCA 9685 because I really want to get that into there. And there's a couple of other little things that I wasn't really happy with when I finished. So I've removed all the screws. These were just screwing into plastic with metal threads. I wasn't real happy with that, particularly with the servo bed. While most of the force is pulling in that way, it can lever up and pull out. So I want to put the inserts, so these things, into the bottom down here. This is attached with a screw through here and into an insert, and this will just have a twisting motion on it, but if I'm going to go to the trouble of putting a metal thread into these two, I might as well do it on that one. So install a metal thread in there, and this piece here is still going to be used. That mounts here, and again I like the idea of a metal thread in that one. Metal threads allow for more accessibility in as much as with a screw like this tapping into the plastic, they're good the first time round. After about 4 or 5 times it tends to strip out the hole, whereas a metal thread you can continually do it up and undo it and then do it back up again. It won't cause an issue. So there's some of the plans for today. Also installing this, I'm thinking of mounting it down here, but this framework in here was designed to hold a servo. So I've got an old servo floating around here, and it was designed to hold a servo in this orientation. And do you think I can get this to fit in there? Got it up in a little bit too hard. In any case, it's not going to get used because we've now got a servo running up to around about here with a shaft going up that way. It will fail, so we can't use it, in which case I can remove it, and that'll give me a bit more clearance, a little bit more room for electronics. The only electronics I really want to install in here is this one. Ideally I'd like to sit it down here further, give easy access to these, and I'll probably hot melt glue it into place. This is where our main power wires will come in, control up this end, and that'll allow a pass through of the I2C from this end up through and into the hand. When I get to the hand, I plan to put in a pair of these. So these are ADS 1115 4-channel 16-bit, I think they are, or it might be 12-bit analog to digital converters. So 2 of these will give me 8 channels, and I need 5 for the fingers. There's no reason why I can't use the spare channels for things like temperature sensors. So I could put in, say, the palm and a couple of the fingers temperature sensing, which could be useful down the track. This module is supported within my robot lab as it is. So is this one. The other thing I'd like to put in, there is a service for it. This is a NPR121. This is a 12-channel capacitive touch sensor. 8 of those channels could be used for LED drivers, so you don't have to use all 12 as touch sensors. You can use a mix of LED driver or touch sensor with a minimum of 4 touch sensors. And there is room in the hand to put 1 of these and say 2 of these, and that will give me the ability to put capacitive touch sensing on the hand as well. I have contemplated putting one of these in the forearm as well and putting capacitive sensing on the outside of the arm. That's still something I would need to think about how I'm going to implement. So in the meantime, let's get stuck into it. I think the first thing I need to do is cut these out and then install these nutserts. To cut those out, I'm going to use this. Hopefully it won't make too much mess. It's like a Dremel tool, just a little bit bigger, something I bought a while back. Not too bad. I think that's going to work quite well. Hot glue that into place and it won't move anywhere. And I've got access to all of these terminals. The chip used in these, the PCA 9685, was originally designed as an LED driver. So I may yet use the spare channels for LED indication as well. So there's quite a few abilities there. Alright, let's look at nutserts. For that I will need a soldering iron. Might open those holes up a little bit. So the trick with these is just go easy. Don't try and force it too hard or fast. You'll break something if you do. Just take it nice and easy and you'll get it in there no trouble. And it doesn't take that long. Okay, that's 2. And in theory, they should line up quite nicely. If they don't, so I'll just move that over a little bit. So to do that, I'll just heat it up and drag it over a little bit. And that looks better. Still quite warm. Move that out of the way to cool down, and we'll do this one. So this is where I want the next insert. Now with these blind holes, I may have to run a tap down just to clean them out later on. You may notice that the plastic bulges up around. That's normal, and I'll trim that off later. Just make sure you get that brass below that surface level. And this one, I will have to open this hole out a bit. Looks good. I will have to clean out the hole from the other side a little bit. And this one's still a little undersized, so I'll just open it up. Now you may notice I'm doing these holes by hand. You don't need to run a power tool through them. And in a lot of cases, the power tool will impart a lot of friction, and friction will cause things to overheat. Now one of the things I'll probably do is also put the inserts in here to better hold our servos. I may yet do that for all of these. I'll see how we go. I can always come back to them later. That's upside down. That's better. So I have got a little bit of a bulge here, and I'll sand that back with it, or file that back. And we'll put a screw in, and that'll complete that part of the assembly. They're still quite warm. Alright, turn the soldering iron off because I don't need that for a little while now. What we do have is this is going to be on the servo. It'll act as the servo horn. This was printed flat as 2 halves, which we then can either glue or weld together. I'm going to weld. And that slots into that slot there and drives a matching one up inside here. So you can see right down the hole there, and that slots in like so, and then that operates the rest. So I need to weld this up, hot melt glue this into place. I might hot melt that glue into place when this is in. And I need to bend these pins over so they're easier to connect my supply into. Yep, no, that works. And we need to install some servos. So I've used these ones in the past. These are the Gael F39202 270-degree digital servos. Now they work. They have some interesting little quirks, and I have got a heap of these, so I will be using because I have got a heap of these. They are very powerful. They're very strong. One of the quirks they've got is if the pulsing coming through is inverted when it pauses or stops, it will cause the servos to suddenly go to one extreme and even destroy themselves. So it's something that you need to be aware of when using these. It is a bug in the firmware within the servo, and there's also a bug within my robot lab where it will pause with the signal high instead of pausing with the signal low. Remember, this is looking for a positive signal for between 500 and 2500 microseconds. So holding it high is not the best solution. Alright, so let's get back into cleanup. Might have to clean that thread out. Much better. Too short. Yep, I got plastic build-up in there. I'll have to clean that out too. For those interested, that screw is a 10mm long M3 screw. Now, when I printed this, I did print it with a slight amount of a slightly reduced horizontal expansion than I would normally print. So if you're printing parts like these where tolerances are important, you'll have tuned your horizontal expansion to -0.1 or -1.15, as I did with mine. But in this case, I reduced it to -1.3 instead of -1.5, so that this is a little bit tighter on the spline. This is PTEG, so there is a very slight, I don't know if you can see it on the camera, but there is a very slight bit of splining in there. And so it lines up, you can feel it when you're installing it, where it does lock in. So that'll help it to lock better. When you get servos as powerful as these ones, 35 kilogram torque, they can actually strip out that spline. Right, I'm going to get my tap handle because it's going to be easy to do these with the tap handle, and I'll be back. Much easier with the right tools. Much better. I'll probably have to pull this back out when I install these servos and these two outer servos. I do have to have that screw in before I install this servo, but its wire will feed out the front here. Now, if you're doing a standard build of an Inmoov arm, then you won't be using one of these for a start. You'll have a Nervo board which will slot in around here somewhere, and you'll plug all your servos into that Nervo board. Now, if you're building the new hand, or if you've managed to set up the analog sensing on the original hand, then there will be a satellite analog board that will be part of the Nervo board kit, which you'll need to slot in here somewhere for all the sensor wires that are in the fingertips to connect into. But I'm doing a non-standard build, so I will be using this, and I will hot melt glue that into place. I can still get to all of these terminals, and I will have a plug on the end of this. I'll bend those pins down so it's easier to connect those, and then I'll run a ribbon cable up here. I will be doubling up on the cores in the ribbon cable. At some point I have to install a switch mode power supply. For those who have followed along on the Fred build in the past, you'll be aware that I use some fairly beefy switch mode power supplies, and I run 20 volt on my system. So I'll be using this to take the 20 volt DC coming in here and give me 6 volt DC coming out here. That will probably be mounted in the bicep area of the arm, because there's just physically not enough room to mount this in the hand or in the forearm anyway, not with 6 servos in there. Okay, so yeah, in the past this servo was mounted up here and drove directly, but it gets in the way of all the PTFE tubes in the new design. Now I've actually printed these off. These I've printed in PTEG, and again I've printed them slightly undersized on the insides. The outside will be exactly the same by changing that one setting, the horizontal expansion. Remember to set it back if you do that for when you're printing other parts, because your tolerances are required for it, and that makes that much tighter. and then we might have to open up this hole to suit the screw for the servos, and these get mounted in here. These ones back here, and these ones up this way. No, it's the front one like that. These two are mounted that way in there, and these might be easier to do with it out of the carriage. Now, modifications on the standard build instructions. We're going to be running PTFE tube up through the wrist and into the hand, and you'll see more of that when I get to doing the hand. This is the PTFE tube I'm running. So you can see it's got a very small diameter. I think it's 1.5mm diameter inside and 2.5mm diameter outside. And these poke through these holes very easily. I haven't had to drill these out at all. Sorry. There. So yeah, these are the standard ones. They were designed for 2 runs of the fishing line. With the new hand design, it's a single run for each finger, so there's only 5 of these coming back, but they do go through the holes in the back here, and I've got them hidden behind this. So they poke through there. There. Through there. And onto the horns. Now, what I'm planning on doing that's a little bit different to the instructions is I'm going to add some heat shrink on either side of this and shrink it down. That'll stop this sliding back and forth through there. So between there and the servo horn, which will be up this end, that's where our wires go through there. That will be our pull run, and this won't be able to move. And since I'll also locate it properly in the finger end, and it won't move, it doesn't matter what flex happens through the wrist, it won't affect our tension. So that's my plan anyway. We'll see how that goes. A little way off that. Let's get the rest of these servos in. So pull this carrier out. I may yet have to put nutserts on for all the servos. We'll see how it goes. It will be room for screw heads. It's good. Not a prayer. Nutserts all the way. I don't know if you can see that or not in the video, but just after I take the soldering iron off, these spring back up a little bit. So push them down a little bit further so that it allows for that spring back. The other thing to note with these is they have a narrower, flatter side, and then they've got the knurls on, in this case in the middle and up here. There are a number of different varieties, but most of them do have a flat side. That goes in first. After all that, I am going to have to take this off in order to get to these screws with the body of the soldering iron. might clean that out a little bit more. I think there's still a little bit of rubbish in there. Now these last two are going to be interesting, being so close to this block. I've tipped the block just here and here with the soldering iron, so I'm going to have to clean that up with file, and I'll have to clean up all of the servo mounts. So if I grab a standard servo, poke that through, I need to clean up all this swap from my desk. I'm going to have to straighten the wires up a bit. That looks alright. Last one. This is always going to be the hardest one to put in because I've got that screw at the bottom which I have to put in before I can put this servo in, and that prevents any sort of flex in this once it goes in. So let's try and get all this assembly in. Now I am going to have to pull this top cover off the wrist at a later date. So if the alignment's not quite right, I'm not real panicked about it at this stage. I should plastic weld this up before I get too far though. So this pen has two settings. It has ABS and it has PLA. I'm using the ABS setting as the high temperature for use with PTEG. Now I have got another one of these horns printed out. This is where I discovered that sometimes I need to make them a little bit undersized. but it'll work for this. You can see it's much looser. It's also looser on the servo, which is why I'm not going to use it. Very hard to see that joint. One of those parts where ABS would be the far superior choice because you can acetone weld it. Still a bit of clean up. Got some over extrusion there. Don't get too much closer to the edge there. That'll be fine. Okay, I'm quite happy with that layout. Okay, so time for horns. And for that, I need a servo tester. This one here. That will work. And that hole's not big enough. We're worried about that servo. I might have to replace it at a later date. Like it's sluggish to react. Seems to be alright now. Could be just a connection to the controller too. I think I might have to adjust that later. Like I said, I'm going to pull this apart. I can adjust it then. Okay, so that's all our servos installed with their associated horns. The next thing I need to do is install the PTEG 9685 and get those all connected. I've still got to replace this with a bent horn pin type or bend it over, and then run all the wires from the end all the way through. You may do a little bit more cable management in there as well. I've also got to take ribbon wires from the ends here through here and into the hand. So I'll continue that on the next video, but for the moment this is as far as I'm going with this part. I might just drop that in there so I don't lose it. It appears to be that part that didn't used to fail, so it's probably needing a little bit of clean up in here to let it sit down a bit lower, I would say. Or I've got a screw sitting up too high. So that's on my to-do list. Make sure all your screws are in properly. It does pull back, it's just a little bit tighter than I would like. If you like these videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to support the channel further, I do have a Patreon account, and I'd like to thank my long-term Patreons, VIPs Go Lucky and Lorenz Berger, as well as my Builder Patreon, Al Morales 45. These Patreons have all been a supporter of the channel for almost 12 months now. If you have any questions, don't forget to ask in the comments or join the Discord and you can ask questions in there. I do see comments in the Discord or questions in the Discord a lot earlier than I do anywhere else, and we'll see you in the next video.